Today's lesson is for notes on page 37 in your spiral notebook. So right now you should have this paper out on your desk, and what we're going to do is fill in this page of notes regarding isosceles triangles together. First thing is we should already know that isosceles triangles have two congruent sides, and if you didn't know, they also have two congruent angles. So let's go ahead and discuss through some vocabulary regarding isosceles triangles. The first is called the base. So what we're going to do, go ahead and draw on your triangle, label this A, B, C, and go ahead and mark AB and AC congruent to each other. So looking at our picture, the base is the non-congruent side. The easiest way to find the base is find the two sides that are equal, and that is going to be your base. So the base is the non-congruent side. It's like the odd side out. Nothing is equal to the base. Next, you come to base angles, and base angles sit on the base. That's why they're called base angles. So base angles are the congruent angles on the base. So sitting on the base, these are called base angles. So looking at your picture, the base is side BC. That would make angle B and angle C base angles. So the base angles sit on the base, and they are congruent to each other. Base angles are congruent. So that's angle B and angle C. And those are base angles. They sit on the base. Next, we come to the legs, and the legs are the congruent sides in your triangle. So looking at your picture, the first congruent side would be AB, and side AB is congruent to side AC. Those are called legs. Okay. The legs are the congruent sides. The last piece of your isosceles triangle is called the vertex angle, and the vertex angle is the non-congruent angle. The vertex angle is created where the two legs meet. So in this case, angle A would be considered our vertex angle. So remember, sitting on the base are base angles. The two congruent sides are called legs. The legs come together and they form angle A. So the legs of the isosceles triangle form angle A. Sitting on the base are the base angles. So let's jump down to a theorem regarding isosceles triangles. The first is about how to determine what is congruent, and this is called the isosceles triangle theorem. Okay? This theorem states if two sides in a triangle are congruent.
Did you talk to Sedline?
No, I'm filming. I'm filming and I can't pause it. It's okay. No, I don't think we're having a meeting. Okay. It's okay. If two sides in a triangle are congruent, then the opposite angles. Okay, I think my pen is dying. Here we go. Then the opposite angles are congruent. So if two sides in a triangle are congruent, then the opposite angles are congruent. What that means is the two sides that are congruent, remember, those are your legs. So that would be side AB and AC. The angles that are across those two, those are referred to as the opposite angles, and those, again, those are our base angles. So across from the legs are our base angles. So that means they're congruent. So what this means is from the angle if you go from the angle, you can point to the two sides that should be equal to each other, and vice versa. If you know that these sides are equal, the angle opposite of those are congruent. It kind of makes an X. The last theorem is called the Isosceles triangle perpendicular bisector theorem. Okay. The isosceles triangle perpendicular bisector theorem. Now, that seems like a lot of words, but remember, isosceles triangles, we know what that is. A perpendicular bisector divides a segment into two equal pieces and makes 90 degrees, and a theorem is just a math fact that has been proven. So given this triangle, what we're going to do is actually create a bisector. So we're going to write the theorem first and then kind of draw it on our picture. The theorem states if a line bisects the vertex angle in an isosceles triangle, then the line is a perpendicular bisector of the base. Now, this sounds like a lot of words. It's a big theorem, but they're all words that you should understand. So let's kind of piece it apart. We have our legs of our isosceles triangle, and angle A is our vertex angle. AC is the bisector. It's the line that's cutting the base in half. So what this means is, let's say that this angle is 30 and 30, because remember, these would be base angles, making these two angles equal. If we were to ignore line AC, these are base angles. And let's say that this angle up here, these would both be 60. So as a whole, angle A is equal to 120. But since angle A has been bisected, each small piece is 60. So I'm using the same color that I used up here for vertex angle. So whatever color you use to match it. So if a line bisects the vertex angle, which it did, then the line is a perpendicular bisector of the base. What that means is this angle down here will be 90, and base BD has been cut in half. So that would mean that BC is congruent to side CD, making point C a midpoint. Okay. So what you have happening in this theorem, and what's happening, is we have a perpendicular bisector of the base. Perpendicular meaning the 90 degrees are being formed. Bisector meaning these two sides are equal. What you actually end up having are two congruent right triangles. You have a triangle located on the left. Okay, you've got a triangle here. And then you also have a triangle located on the right. These two triangles would be congruent. And we haven't talked about triangle congruency yet, but we will on Monday. So what ends up happening is triangle ABC is congruent to triangle ADC by a reflection over segment AC. So what ends up happening, if we were to take our triangle and reflect the yellow one on the left over side AC, it would in fact flip over and be equal. And we don't have an opportunity to do this right here. This is basically your notebook. Notice here, if I can actually pick it up and flip it over, and it matches perfectly. If I reflect the left triangle over line, technically we called it AC in your notes. If I flip it, Notice how they land exactly on top of each other, creating two congruent right triangles. Now your paper is just flat, but it's the same idea. I can take this yellow triangle, flip it over AC, and these two would match. So that is called the isosceles triangle perpendicular bisector theorem. Please make sure that you glue this onto page 37 in your notes.